Phobos falls, slowly, inexorably, directly on Mars, and every year it descends by about 2 centimeters. In some 50 million years, everything will end, but not with a collision. Mars will tear it apart long before that, because at some point Phobos will be so close that the planet's attached forces will begin to pull it from the inside in different directions, and rings will appear around Mars like those of the Saturn. Just imagine a red planet, and around it is a sparkling ring of debris from what was once its closest satellite. It will happen, it is already a foregone conclusion, and the only question is whether we will have time to find out what Phobos is before gravity destroys it. And now a Japanese probe flies to this dying piece of stone. Why Phobos is important, why it is, and why right now. Let's start from the very beginning, from the moment when this strange body was found at all. In the year 1877, American astronomer Asaph Hall works at the Orion Naval Observatory in Washington, D.C. Mars is particularly close to Earth this year, a big opposition, one of those moments when the planet is most visible, and Hall has been looking for Martian moons for several nights. Most colleagues are sure, don't search, you won't find it. On August 11th, he notices something near Mars, a foggy spot, incomprehensible, maybe a cloud, maybe cloudy air, he is not sure and just waits. A few days later, on August 12th, he again observed the same place and saw 2 objects at once. One closer to the planet, the other farther away. He spends the whole night without looking up from the telescope, and by morning there is no doubt that these are satellites. Downey was called Deimos, fear, and Bielizny was called Phobos, horror, after the sons of Ares from Greek mythology, the god of war, to whom Mars corresponds. The discovery amazed the world, but even then it was clear that these objects were strange. Phobos is too close to the planet, Deimos is too small, ordinary moons don't look like that, and Asaph Hall didn't know that he had discovered not just 2 moons, but the 2 main questions of the next 150 years. Where did they come from and what would happen to Phobos next? When you look at Phobos in the pictures, the first thought is that it's not the moon, it's a potato. Uneven, angular, 17 kilometers long and about 11 kilometers wide, all in craters, and the largest of them all, Stickney, occupies almost a third of its entire visible surface. A crater 9 kilometers wide on a body the size of a small city, and nothing holds. But it's not about the form, it's about the orbit. Phobos flies around Mars so low and so fast that from the surface of the red planet it can be observed 3 times a day. It rises in the west, moves east, and in about 7.5 hours makes a full rotation. A Martian day is 24 hours and 37 minutes, and Phobos circles the planet 3 times during this time. This is not the normal behavior of the moon. No other moon in the solar system moves faster than its planet, and that's why it's falling. The forces that keep it moving quickly against Mars' adaptive braking lose a little bit every year by the same 2 centimeters. Deimos behaves differently. It moves farther, smaller, slower than its planet, and slowly moves away from it, just as our moon moves away from the Earth by 3 or 4 centimeters per year. Deimos will eventually leave. Phobos will fall, such is the fate of the brothers. Now, the most important thing is what they are and where they came from, and this is not just an academic question because the answer depends on what exactly we will find when we get the soil. The first version is captured asteroids. For a long time, this was the standard in textbooks. Look at Phobos and Deimos, dark, uneven, with low reflectivity, and spectral analysis showed similarities to carbonaceous chondrites, a special type of asteroid from the outer part of the main planet, rich in organic matter and bound water. Logically, Mars just caught a couple with its gravitation. The problem is in the orbits. Captured objects should have elongated, inclined orbits, and Phobos and Deimos fly in almost perfect circles and almost exactly in the plane of the Martian equator. For an accidental capture, this is too neat, too correct. The second version is the fragments of Mars. A gigantic impact billions of years ago, a large body crashed into the young Mars, threw a huge amount of material into space. Some of it formed a disk around the planet, from which Phobos and Deimos gradually stick together. This is how, according to our best understanding, our moon was formed. This explains the orbits, but it doesn't explain the spectrum. If they're made of Martian material, why do they look like asteroids, and why don't they look like Mars? There are several answers. Space weathering is a constant bombardment by micrometeorites and the solar wind that changes the spectral characteristics of the surface. Or the impact was so powerful that previously captured asteroid material entered the ejection. Or the surface over billions of years has been covered with dust that flew from Mars during shock emissions, and it is this that spoils the picture. The third version is a hybrid. Phobos is originally asteroid, captured a long time ago, then destroyed by a blow, then reformed again, and a loose porous structure is the result of several generations of destruction and assembly. All three versions are competing models. Good scientists defend each with data and calculations, and there is no final answer until a direct analysis of the soil. Now let's talk about payability, because this is one of the most amazing characteristics of Phobos. When its mass and volume were calculated, the average PVD was about 1.9 of a gram per cubic centimeter, and water was 1 gram, the lunar region was about 1 in 8, and ordinary rock was 2 or 3 and more. Phobos is literally lighter than most rocks, and this suggests one thing. There are many voids inside, perhaps up to 30% of the volume, just empty space, a loose pile of rubble, barely held by weak gravity. Or not a loose pile. This is where the story that they like to retell begins. In the 80s and 90s, with the advent of children's photographs, Phobos surprised again. This time with borazed parallel stripes on the surface, long, surprisingly straight, several families of different orientations. Conspiracy theorists were not confused. Traces of the landing gear, infrastructure, docking guides, proof that there was a base inside, or an alien ship in disguise, or a Martiana hid something there before their civilization died. Scientists explained more boringly. The most convincing version now is that the borzos are traces of secondary impacts. When large asteroids crashed into Mars, they threw debris onto high orbits. Some of these fragments fell back to Mars, and some flew further and touched the Phobos tangentially, rolling along the surface and leaving chains of craters. Another version is that borons are cracks from additional deformation. If the Phobos is loose and Mars constantly crushes it with its gravitation, structural stresses come out in this way, and then borons are the first symptoms of destruction, not in 50 million years, but right now somewhat, but already. Now about landing, because from a physical point of view, this is one of the most non-trivial tasks in the history of cosmonautics. Phobos is small, the acceleration of gravity on its surface is about 1,000th of the Earth's, and if you stand on a Phobos and jump not very much, you will fly into outer space because the second escape velocity for a Phobos is only about 11 meters per second, which is a little faster than the average athlete runs. The standard technique, brake, descend, land, does not work here in the classical sense because there is a huge Mars hanging nearby which is also pulling, and the device is located at a point where the gravity of Phobos and the attraction of Mars literally pull in different directions, and this must be taken into account every second of the maneuver. The Japanese strategy for MMX is a short touch, not a long landing for hours or a day, but a few minutes, enough to grab the ground with a special pneumatic mechanism. The probe touches the surface, shoots a probe, grabs the material, and immediately back to the top. But another problem is that the surface of the Phobos is covered with regolith, a loose layer of dust and fine rubble, the exact depth of which is unknown, as well as the hardness, and it is not clear whether the probe will fall deeper than planned. It is like jumping on a trampoline without knowing what it is made of. That is why before landing, the MMX probe will conduct a long orbital study. Centimeters in several bands, laser spectroscope directly from a distance, a neutral spectrometer to search for hydrogen and water in the regolith, the Maris radar instrument to probe the surface from the inside. It may answer the question of transparency and internal structure. A surface map, a composition analysis, the selection of 2 points to sample, and all this work will take not days but months, because the Japanese are not in a hurry when it comes to reliability. Why the Japanese? Because Japan already knows how to get soil from space, and already twice. In the year 2001, the Kayabuse probe, which means peregrine falcon, returned the first ever samples of matter from asteroida Itokawa to Zemlya. The mission was catastrophic from a technical point of view. Engines broke down, several systems failed, the probe lost contact for several weeks, but when Kayapsula landed in the Australian desert, there were grains of dust from asteroida inside, small but real. In 2020, Kayabuse 2 did the same with the asteroid of Ryugu, and much cleaner. He took samples from 2 points, one of which he created himself, blowing up the surface with a special charge to get to the material from under the regolith, and brought back about 5 grams of matter, which gave a huge amount of data about the history of the solar system. JAXA is not an agency that only dreams. It is an agency that flies, breaks, repairs right in flight, and still brings results. MMX, Martian Moons Exploration, and the name says it all. The probe weighs about 3,000 kilograms at launch, large by the standards of research vehicles, because it carries a re-entry capsule with samples. He doesn't just fly and study, he flies, studies, lands, takes, returns, sends Kayapsula home. The return scheme was tested on Kayabuse. The Kayapsula with samples enters the Zemlya's atmosphere, breaks, the parachute opens, and the box with soil gently lies on the ground in the Australian desert, where a special training ground for such landings has already been equipped. The launch took place in 2026. Arrival to Mars is expected in about 3 years. Then about 3 years of work in the Mars system, and return with samples by 2033. The response time to the command signal is from 3 to 22 minutes, depending on the relative position of Mars and the Earth. There is no remote control in real time. The probe makes decisions on its own, and you send a command, and you find out what happened only after 40 to 45 minutes. It's scary from an engineering point of view. You can't fix a mistake on the fly. Everything that can go wrong must be foreseen in advance. Every scenario in the program, every possible failure with a restock protocol. JAXA can do it. Kayabuse the first lost 3 of the 4 flywheels, damaged the solar panels, lost the fuel of the ion engine, and still flew back on reserves and on the stubbornness of the engineers who worked with the disabled device for 3 years and forced it to return. MMX is the 3rd level, further, heavier, more difficult. What will the soil from Phobos give us? If Phobos is captured by an asteroid, its substance will tell us about the primary building material of the solar system. Carbonaceous chondrites are one of the most ancient and primitive objects that we know. They may contain organic molecules, amino acids, water in the form of hydrated minerals, literally the ingredients of life, preserved from the very beginning. If we have a piece of the planet in our hands, and from deep layers where no rover will ever reach, we can find out what Mars was like billions of years ago, before it lost its magnetic field and atmosphere, before it dried up. An isotopic analysis will show where the material comes from what part of the solar system, in what epoch it was formed. Organic chemistry, whether there are traces of complex molecules, precursors of amino acids. Mineralogy, what are the silicates? Are there any signs of a change in rocks indicating contact with liquid water in the past? If they find organics, not life but chemical building blocks, it will add to the debate about how widespread organic matter is in the solar system. Any result is important because in science, we didn't find what we expected is also an answer, sometimes the most important one. The Japanese expect to bring back at least 10 grams. Less than a coin, but more than anything we've ever known. There is one more aspect that is rarely talked about in the context of Phobos. It is like a Riyadh station. If one day people fly to Mars, and they most likely will, the only question is when Phobos becomes a strategically important object. It is convenient to observe the surface from it. Fuel depots can be placed on it because pulling something from Phobos to Mars requires minimal energy costs, and it is more convenient to control drones and robots on the surface of Mars from Phobos because signal latency is seconds, not minutes. Some engineers are seriously proposing to build an intermediate base on Phobos even before the manned landing on Mars. It is physically easier, safer, and cheaper to land there than on the planet itself. MMX is the first real step towards this future, the first time that a human device will not just take a picture of Phobos from a distance, but sit down, touch, and take a piece. If you were standing on the surface of Phobos at a point facing Mars, you would see Mars huge, occupying 25 degrees of the sky. 40 times larger than the moon in our sky, red, slowly rotating with volcans, canyons, and polar caps perfectly visible from that distance. The dust under our feet is gray-brown, craters are everywhere, the horizon is very close. The curvature of the surface can be felt literally a few hundred meters away, and beyond this horizon there is neither the sky nor the soil but the stars at once. The boundary between surface and space is almost blurred. And a few years later, a Japanese spacecraft would fly to this strange place. Without pilots, without spectators, only the algorithm and engines, and commands from the control center in Sagamihara, Japan. In about 7 to 10 million years, Phobos will cross the Roche limit for Mars, the distance closer to which the planet's orbital forces tear apart a solid body, and if Phobos is loose, as many people think, it will begin to crumble even earlier. Mars will literally stretch it into a torus, a bagel made of stones, and then smear this bagel into a ring. Some scientists believe that Mars has already had rings in the past, from previous moons, and then reassembled them into new moons. This would explain the strange orbits and composition of the current moons, which may be in the third or fourth generation. The moon appears, falls, becomes a ring, the ring sticks together into a new moon, and so on in a circle, and we don't know how many times this has already happened. Maybe Phobos is not the first one, and definitely not the last. When Apollo 11 brought back the first 22 kilograms of lunar soil, it was not just science, it was an announcement that humanity knows how to take samples from other worlds, that the moon is not just something in the sky, but a place where you can come and return. MMX does the same for the Mars system. Think of it this way: 2 meters of rock that has survived 4.5 billion years and is now flying somewhere between Earth and Mars will soon be in the hands of a scientist standing in a clean room in a laboratory where not even dust is allowed, and then years of analysis, isotopes, molecules, history. We live in a moment when all this is happening not in books or in hypothetical reasoning, but right now, while you are listening to this, somewhere between Earth and Mars, a Japanese spacecraft is flying with a specific task: to fly to the dying moon, land on it, not break down, take the soil and return. Phobos continues to fall at least 2 centimeters a year, and in 50 million years it will be gone, only a ring around the red planet. But first, he will tell us where he came from, through samples, through years of work by scientists who will get these 10 grams and disassemble them atom by atom. 200 million kilometers there, 200 million back, 7 years, 10 grams. That's what humanity does when it wants to understand where it lives: patience, precision, and a stubborn desire to know.